But something like this would be an enormous benefit for dealing with those slightly slower systems, the drones and cruise missiles that are being launched against them, and would enable them to save kind of the quite scarce Patriot systems for some of the larger targets, or the things where they would want to basically shoot at them from a greater distance. So DragonFire is a directed energy weapon, a laser basically, and that works essentially by focusing energy, light in this case, to have an effect on whatever it's basically being pointed at, and that can vary depending on the output that it's said to. So at the high end, effectively, it's burning through a target, it's creating heat damage, but you could also use it to dazzle sensors or otherwise interfere with the electronic systems, but without creating the sort of the same kind of damage. Well, so lasers have a number of advantages and disadvantages when compared with existing systems. You know, in the example of being air defense, where you would potentially use a combination of missiles or guns, basically firing bullets or shells or something at an incoming target. The advantages are that you're not expending ammunition. As long as you can power the weapon, you can continue to fire it, and some of these weapons in theory are quite cheap to operate, so that the calculation of a few pence or a few pounds in terms of the electricity, the power required to fire the weapon, compared with air defense missiles, where some very expensive ones or large ones like the Patriot system can be hundreds of thousands of pounds or dollars per missile. And some of the challenge that we're seeing in places like Ukraine at the moment is that the range of incoming threats can vary from very fast cruise missiles to slow-flying drones to things that sit in between. And the challenge for the defenders, in this case the Ukrainians, particularly as they run short on those missiles, is both you can literally run out of things to fire, but also you might find yourself in a situation where somebody is launching a lot of relatively slow-moving or cheap missiles at you, and you have to use your expensive high-end defensive missile to shoot those down, and then you get hit by something that's much more damaging. So a laser can be very, very cheap compared to that. It's also fast. So a laser is essentially a beam of light. Therefore, it strikes the target essentially at the speed of light. So provided you have an accurate tracking system, so can target the incoming projectile and then track it as it's moving at you, you don't have the time taken for a missile to launch, acquire the target, and then fly towards it and strike it. There are downsides, of course. So a laser, as a beam of light, moves in a straight line. It is limited by the curvature of the Earth and its range. Some ground-to-air missiles, if you detect an incoming target from dozens and dozens of miles away, or if you have an airborne radar that can see those targets coming in hundreds of miles away, you can launch very long-range surface-to-air missiles at it, and they can defeat it when it's quite a distance from the target. A laser, unless you mount the laser on something in the air, it can't do that. There is also the issue that some weather conditions or atmospheric conditions can interfere with the laser, because it's a focused beam of light, and so you can get diffraction under certain circumstances, for example, humidity or cloud, although you can overcome that with essentially power and how you focus the weapon, so you don't suffer so much degradation of the beam, basically. The question of how soon you can get it out in the field, 2027 is the time that they're talking about it now being ready for operations, so brought forward by a few years from the original target date. I think, though, we have to bear in mind that, for example, this weapon has predominantly been borne in mind for mounting on ships. So one of the other issues that you do have with it is you have to generate the power to fire the laser. Now, you don't need necessarily like vast amounts, but you do need some kind of power source, be that an energy grid or something else. So at the moment, for example, this would only be able to be operating around a fixed site. You couldn't mount it on a vehicle right now, although maybe in the future, particularly if you miniaturize it. One of the reasons why it's well suited in our minds to mounting on ships is because the Royal Navy's current destroyers and all the future ships it's building actually generate power from their propulsion system and can quite happily mount several of these weapons. It's also because, as well as drones, you could use it against small boats and other fast-moving targets around the waterline, or at sea level, effectively. So that's what it's got in mind. I'm not convinced that you're going to see it turning up in, say, Ukraine in the next 12 months. We've only got one of them. But the development of these kind of weapons is the kind of thing that could be brought in a few years to complement other ground-based systems. The Russians at the moment are spending an awful lot of focus on Ukraine's energy infrastructure, and you can probably expect them to continue to do that over the next couple of years. But something like this would be enormous benefit for dealing with those slightly slower systems, the drones and cruise missiles that are being launched against them, and would enable them to save kind of the quite scarce Patriot systems for some of the larger targets, or the things where they would want to basically shoot at them from a greater distance. The current kind of class of directed energy weapons that are being developed probably have very broad applicability. You probably wouldn't be able to use them at the moment against a lot of ballistic missiles, for example, because those are already shielded against heat, because a number of them essentially have to re-enter through the Earth's atmosphere, and so you'll find a laser might struggle against them at the speed at which they effectively descend. But it would be incredibly useful against some cruise missiles, lots of drones, and smaller targets. There's definitely a strand of UK thinking over the past few years that has become more interested in innovation and technology, and you can expect lasers, DragonFire, other novel or directed energy weapons to play a part in that. There was an announcement about kind of a new innovation centre, although the MOD has had an innovation unit for some time. It's got a defence and security accelerator, as it's known already. So it's not clear how much is entirely new, but there's a strong recent interest in lots of these kind of things because of the need to use them or develop them against other developing threats. However, I think what we are seeing, particularly in Ukraine, but in other conflicts, is a cautionary tale about assumptions that new technology will completely change the way that warfare is conducted, and particularly that they can be a substitute for numbers. What we're seeing is, in Ukraine, artillery has been the single largest killer over the past 12 months. It's not been drones, although they play a significant role. They complement artillery. There is still a role for standard armor. We're seeing the way that weight of numbers has been having an influence on the battlefield. And so I think one of the questions about how the UK chooses to spend the additional money that's coming into the MOD is not placing too many bets, or perhaps not putting all of its chips on innovation and technology, when a lot of what we can see at the moment is the need for people and numbers. Not least is because actually the number of weapons you've got matters to the amount of ultimate damage you can do to an adversary. And if you're facing somebody who has their own significant mass, the danger is that you can't do enough damage to either deter or dissuade them. And a good example in Ukraine is that the Ukrainians have very successfully used precision cruise missiles provided by the UK and France against Russian arms dumps, headquarters, and other targets. And that has successfully done significant damage to the Black Sea Fleet. It had a lot of other targets supporting the Russian army on the ground, but that in and of itself hasn't turned the tide of the battle along the front line. So I think we need to be cautious about technology being a panacea for lots of classic use of the military force. What the UK included in its most recent package announced this week was more air defence missiles. We've already provided them with a variety of smaller systems, largely based around the Starstreak weapon, including some that were mounted on vehicles. And also we've actually converted some air-to-air missiles. So in the near term, that known proven technology that is cheaper than a very large Patriot is the kind of thing you're more likely to see turning up in Ukraine. But down the line, directed energy weapons and other forms of perhaps disrupting or interfering with missile guidance could begin to have greater utility. So, I mean, directed energy weapons, lasers in particular, have been a source of research and interest for decades. The US previously looked at and was trialing an airborne laser mounted in basically an airliner for use in missile defense. Of course, I think people remember the Strategic Defense Initiative, the so-called Star Wars program, and the interest in lasers for ballistic missile defense then. More recently, they have also trialed a laser in a very similar role on one of their ships. Actually, I think it was in the Middle East about 10 years ago, because of the interest in using it to defend against small boat swarms. A number of other countries have been looking at these. I think the Taiwanese are looking at it. So the technology is kind of well known. A lot of the challenge is in miniaturizing it whilst maintaining power output. I think the UK has been rightly quite cagey about what makes DragonFire so special because of the way it can effectively operate and the output they get from the weapon. But the principle is hardly unique. Other directed energy weapons have been looked at. So, sonic weapons or microwave weapons have been looked at, often in a non-lethal capacity. So, in other words, things that you might use for crowd control or where you want to fire essentially a warning shot to keep people back without actually having to use lethal force. That is another one of the advantages of lasers, in that you can vary the power output. And so, as I mentioned earlier, you could use it to dazzle effectively a target. And that's an area actually where the Chinese have done a lot and been accused recently of using lasers to both dazzle sensors, but also people. You can do quite serious damage to a person's retina if they're subjected to a high power laser. So a lot of people are looking at directed energy weapons in a variety of roles.